Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chanapkut. Dear students, in the previous class we were discussing about conduction heat transfer, convection heat transfer. What is convection heat transfer and how to calculate the convection heat transfer rate. Okay, and what are the different types of convection heat transfers are there that we have discussed in detail in previous class. Dear students, come, we will move towards next topic. So before going to next topic, what I will do, dear students, I will try to do one small numerical on convection heat transfer. So one small numerical on convection heat transfer. So first I will read the problem, then I will solve the numerical. So first one, a plate 1 meter into 1.5 meter is maintained at 300 degrees Celsius, full stop. Air at 20 degrees Celsius blows over the plate. If the convective heat transfer coefficient is 20 watt per meter square degree Celsius, calculate the rate of heat transfer. Dear students, what he has done, he has given a plate of 1 meter into 1.5 meter and the temperature of that plate is 300 degrees Celsius, and over that plate what actually he is doing is blowing the air actually. That the air temperature is 20 degree Celsius. So if it's so, how much amount of heat is going to transfer from plate to air is asking to calculate. To calculate that, what I will do, I will try to list out the given data and I will try to draw the schematic diagram which is relevant to the particular problem. This is my first step. So what I will do, dear students, now. So first what I will do, I will draw the diagram as per the given data. So now, dear students, I will take a hot plate of 1 meter into 1.5 meter length. So it is 1 meter in length and 1.5 meter in width you can call. Okay, so it is 1.5 meter and here it is 1 meter. Okay, then with the help of this data, what I can do, I can calculate the area of the plate. Okay, when we are seeing at the front view, this is what elevation or top view. You can see the either sides, length, width also you can see, breadth also you can see. Okay, that I have done. With the help of this data, I can calculate the area. That is fine. Then when we are seeing at the front view, it looks like this. Okay, then the temperature of that plate is 300 degree Celsius. Dear students, as I told, temperature of wall or plate I will represent here as TW. So temperature of wall I can say, temperature of plane I can say, temperature of plate I can say. So that is TW. The TW is equal to how much he has given? 300 degrees Celsius. That means what? There is a hot plate. Okay, the temperature of that hot plate is 300 degrees Celsius. That I have marked. Okay, then what actually he is doing, dear students? He is blowing air over the surface of the plate actually. On this plate, what actually is doing? He is blowing the air. That air is blowing over the surface of the plate. Then that air temperature is, that air temperature I will mark here as a T infinity. The T infinity also he has given, that is 20 degree Celsius. Dear students, you can see here now. The air temperature is 20 degree Celsius. Yes, he has given 20 degree Celsius. That I have marked. Okay, T infinity. The temperature of ambient air I will mark here as a T infinity. That's fine. Now, if it's so, here it is a hot, that is 300 degrees Celsius, here it is 20 degrees Celsius. When the air is moving over the surface of the plate, right, that what will happen now? That air is going to come and it will absorb the heat and it will try to move up. That means what heat is going to transfer from hot plate to air actually. If it's so, that heat is represented as Q. If it's so, how much amount of heat is getting transferred from hot plate to air? He is asking to calculate that. To calculate that, we have an equation. That equation, with the help of Newton's law of equation, we can calculate. Then what I will do, dear students, now, so I will list out, now this is the diagram, schematic diagram I have drawn. Now what I will do, I will list out the given data. So I will write it here now, given data. What all things he has given now? First one, the hot plate he has given, that is length, dimensions of that plate he has given. With help of the dimensions I can calculate the area. So when it comes to area, right, it looks like a rectangular plate. Then area is 1 meter into 1.5 meter. Then what I am going to get? 1 into 1.5 meter is nothing but what? 1.5 meter square. That is area of the plate. That's fine. Then next, the temperature of that plate or wall is how much? 300 degrees Celsius. Then I will represent here TW, that is equal to 300 degrees Celsius. The next, then whatever the air is moving, right, that air temperature is T infinity, that also he has given, that is 20 degrees Celsius, dear students. Okay, fine. Next, then if the convective heat transfer, then here there is a convective heat transfer that is represented as H. That H also he has given how much it is, that is 20 watt per meter square degree Celsius he has given. So with the help of this data, you need to calculate the heat transfer, that to convective heat transfer. That heat transfer may be forced or free convection. To calculate heat transfer, either it is forced or free convection, we are having an equation. What is that equation? That equation is Q is equal to HA into TW minus T infinity, dear students. Okay, fine. Now I will try to use this equation. So first I will try to, now I listed all the given data. Now I will try to substitute all values in this equation. What is H? H is equal to 20 watt per meter degree, 20 watt per meter square degree Celsius is given. I will substitute here. Then area is 1.5, that also I will substitute here. The next into TW, temperature of plate, that is 300 he has given, I will substitute. The next minus T infinity, that is air temperature, that is 20 degrees Celsius. Then I will do simplification. What is how to do the simplification, dear students? You can see here now. Okay, now what is H? H is equal to 20, I will substitute here now, into area is 1.5, I will substitute, into, then what is the temperature difference, that is 300 minus 20, dear students. Then how much you are going to get answer? That is 8400. So Q is equal to, what I can do now, Q is equal to 8400, that is in watt actually. So that I can convert that watt into kilowatt. That is nothing but what? So I will divide it by 1000. So I will divide it by 1000. So when I'm going to do it, divide it by 1000, right, I'm going to convert that watt into kilowatt. That means what? Q is equal to 8.4 kilowatt. This is my final answer. This is my final answer, dear students. Okay, one thing, then how you got the unit for heat transfer is watt here. That is also important, dear students. You can see here now in the H, what is we are having in H, that I will write it here. What is the, once again I will write Q is equal to H. How you got the unit? Watt actually. That's also important. That is temperature TW minus T infinity. So dear students, what I will do here, just you can see here now. So what is the unit for H? That is 20 watt per meter square degree Celsius is there, right? So I will write watt per meter square degree Celsius is there. I have written it here, into what is the unit for area? That is meter square. Then change in temperature, that is degree Celsius. I will write it here degree Celsius. Then I will cancel. Now meter square is there, get cancelled. Degree Celsius is there, degree Celsius is there, get cancelled. Then only left out is what? Watt. So Q is equal to watt. Then that watt can be converted into kilowatt by dividing 1000. This is the final answer, dear students. This is how to solve the numerical. I hope you understood today's problem. If you understood really, please do subscribe my channel and support. Thank you.